Hi guys, I think I'll be starting class right now. So welcome today. Today is lesson 13. We're going to be talking about grams to grams conversion. Okay. So for homework, this week, like all the other weeks, there's going to be 4 questions in a Google Forms quiz at the same place as always. I would highly recommend you to attempt those problems. And of course, I'll give you written feedback and post your grade in Google Classroom as always. And if you have any questions about the homework, if it's confusing, if you don't understand anything in the lecture, feel free to contact me at jasonzhang@alphademic.org. So last week I realized that we were a little iffy on the conversions. So at the beginning of class today, we'll review grams to moles, moles to moles, and moles to gram conversion. And then we'll review the full grams to grams conversion that we attempted last week. This time we're going to have more problems, and hopefully you'll get down that complex conversion because it's common in both normal chemistry as well as AP chemistry. You'll need to know how to do these conversions. So let's start off with reviewing grams to moles, moles to moles, and moles to gram conversions. So these are like the 3 baby steps that entail the next topic, which is grams to grams. Grams to grams conversion requires all 3 of these conversion techniques. So I would like to emphasize that molar mass is the important conversion factor in any stoichiometry problem. So to remind you what molar mass is, it's the sum of the masses on the periodic table. So the molar mass of ethanol C2H6O is 46.1 grams per mole. So if you want to quickly verify, you can recall that carbon is 12, hydrogen is 1, and oxygen is 16. So since there's a 2 below on the carbon, it's 2 times 12 plus 6 times 1 plus 16. And you'll get roughly around 46 grams per mole. And the reason it's 46.1 grams per mole is we kind of estimated on hydrogen. Hydrogen is actually 1.008, which I think it's negligible. It could be rounded to 1. But in a real molar mass, they will use the full term and they get 46.1. So you could say 46, 46.1, they're basically about the same. So since we know it's 46.1 grams per mole, so we know that 1 mole of ethanol is 46.1 grams of ethanol. So we can get this directly from the molar mass. Because the molar mass is at 46.1 grams per mole, and then we can multiply it by 1 mole. So 1 mole is 46.1 grams. And that's what this next statement says right here. So now we have 2 conversion factors that we can use for any stoichiometry problem. We can divide both sides. Sorry about that. We can divide both sides by 46.1. So we divide this side by 46.1. And we can divide the right hand side by 46.1 grams per mole. We know that the right hand side equals 1 since you're dividing it by yourself. So you know that this important ratio is 1. And that's the molar mass that we're going to use in every single conversion. Similarly, we can divide both sides by 1 mole of ethanol and get that this ratio is also 1. So basically, this ratio is basically the molar mass, if you can see. This one is actually 1 over the molar mass. And this ratio right here is just the molar mass. MM stands for molar mass. See, it's 46.1 grams per mole. So basically they're an equality. So we can use any of these in our conversion factors because we know that they equal to 1 always. So this is a grams to moles conversion. So assume we have 10 grams of ethanol and we wish to determine the number of moles. So our first step always is to have what we have, which is 10 grams, and we write it on the left. And then we multiply it by a molar mass. Now we have two ways to multiply it, a 46.1 grams on the bottom or the 46.1 grams on the top. But the thing we want to do in this dimensional analysis is cancel out the grams. So it must go on the bottom so we can multiply these numbers out and cancel out the grams. So we end up dividing by the molar mass in this case. So 10 divided by 46.1 is 0.217 moles. So that's how we do these one-step calculations. So here's a problem I want you to attempt on your own. Please put it in the chat when you got it. How many moles are in 10 grams of nitrogen gas? The molar mass of nitrogen gas, or N2, is 28 grams per mole. So you can put it in a calculator, fraction, decimal, whatever. Answer in whatever form you wish. So it's basically the same process. We want to convert from grams to moles. Okay, I see a bunch of correct answers. So this calculation, you start off with what you have. The only thing you have is 10 grams. The molar mass, we also have that as information, but it's only a conversion factor. So we always start with how much of the sample we have, 10 grams. Now we want to use the molar mass since the molar mass is our special conversion factor. So we have two ways to think. The molar mass could either be on the top or the bottom, but we always want it to be the one where it would cancel out the grams. The only way we can cancel out the grams if it's on the bottom, so 28 grams in 1 mole, which is basically what 28 grams per mole is. And then we could cancel out the grams. So our final answer is 0.357 moles of N2, which I know a lot of you guys got, so great job on that. So, yep. So there's one more problem on this concept before we move on. So it's a similar type of problem. How many moles are in 45.6 grams of lead chromate? PbCrO4 is lead chromate. And note that the molar mass of PbCrO4 is 323 grams per mole. So please PM me when you're done with this question so I can see if you guys understand this concept. Like the last problem, you should always start off with what you have and then convert it to what you want. Okay, so let's go through it together. We start off with 45.6 grams of lead chromate, and then we cancel off with our molar mass. Then we always have to wonder, do we want the molar mass to be on the top or the bottom? And like the last problem, we want it to be on the bottom so we could cancel out the grams. So 45.6 grams. Oh, sorry. It should be 323. 323, not 45.6. And as usual, the grams cancel, and you do 45.6 divided by 323 and put that into your calculator, and you would get 0.141, which is the correct answer. So good job. So that was grams to moles conversion. That's 1 out of 3. Now we're going to talk about moles to moles. So a balanced chemical equation gives the mole ratio. So the coefficients give the mole ratio between any reactants or products. So the easiest way to see the mole ratio fraction is to just take its coefficients. So for example, if we want the mole ratio of, so I'm going to teach you a new way to do it this time, a mole ratio from water to mole of hydrogen gas. You just take the coefficients on each term. So it's a 2 for water, and it is 2 for hydrogen gas. So your ratio is 2 to 2, or you could simplify it to 1 mole of H2O is 1 mole of H2. You can divide the terms and reduce the fraction. So there's 1 mole of water for every 1 mole of hydrogen. Now, if we wanted to do that with oxygen, the moles of water to the moles of oxygen, we can just take the numerator of the moles of water, 2 mole water, and the denominator, we can put the 1 mole of oxygen. If there's not a coefficient, it's assumed to be 1. So this is the mole, this is like the mole ratio that we can use. So how do we use a fraction? Suppose we have like 8 moles of oxygen. We create the mole ratio just so that the moles would cancel out just like the gram conversion. So 8 moles of oxygen, we multiply it by the coefficient we found by taking the coefficients in a balanced chemical equation. And we do 8 times 2 is 16 mole water. The way I taught you last time, which you can also do, you could do like ratios. It's a 2 to 1. So we know it's 8 here. It's 16 here because we multiply both sides by 8. Either way is fine. I'm just trying to teach you different ways. Because in chemistry class, they teach you the new way, this way right here. But if it's easier for you to do this way, stick it with it. Okay. So let's practice that problem for these 2 problems. So when you have it, please put your answer into the chat. Lithium metal explodes in water with the following equation. We've seen this exact equation last week, but I changed the numbers a little. If 6 moles of lithium react with excess water, how many moles of hydrogen gas are formed? So you first want to find the mole to mole ratio between lithium and hydrogen gas. And you can use either methods I just showed you to find how much H2 given 6 moles of lithium. And remember, moles are just a number. So I'll rewrite it color coded. So um, so I have it color coded now. I'll first do my old way and then do the new way, because the new way is how your chemistry teachers will probably teach it to. So we start off with what we have. We only have 6 moles of lithium. So 6 moles of lithium. I'm going to do the new way first and then the old way. Sorry. And then we need the ratio between lithium and hydrogen gas. As you can see, I color coded it. We want the lithium to be on the bottom. So we have 2 moles of lithium per 1 mole of hydrogen gas. We take the 2 from the lithium and the 1 from the hydrogen gas, and that fraction is always equal to 1. And then we cancel out the moles of lithium. So we get 6 divided by 2 is 3 moles of H2. Another way to think about it is lithium to hydrogen gas ratio is 2 to 1. If we have 6 moles of lithium, how many moles of hydrogen? 2 to 1, so we're multiplying by 3. So we're going to do 1 times 3 is 3. So 3 is the correct answer for that one. Now, let's do the second one. Whoopsies, I didn't mean to erase all of it. So we start off with 5 moles of hydrogen. And we want the moles of lithium. So we want the ratio between lithium and hydrogen. This time, since we start off with the moles of hydrogen on the top, we want the moles of hydrogen on the bottom. 1 mole of hydrogen is 2 moles of lithium. Of course, with the same balancing coefficients. We cancel out the moles of hydrogen, so we get 10 moles of lithium. We can also do it by proportions. Lithium is 2 to 1. So we have 5 here. We multiply this by 5. So this would be multiplied by 5 as well. So we get 10. So either way, we get 10 moles of lithium. So this is an important part of our grams to grams conversion. We're going to have to convert between the mole ratio between 2 compounds, because a chemical reaction only tells us the molar equivalence. So we can convert between moles with our chemical equation. That's the importance of it. Now our last thing is moles to grams review. So this is almost the same as the grams to moles, but it's in reverse. So suppose we got like 0.217 moles of ethanol and we wish to determine the number of grams. As always, this right here is the molar mass. Molar mass is going to be our only way to convert between moles and grams. But this time, notice that the 46.1 is on the top. That's because we want to cancel out the moles. The moles cancel out when we multiply, so we're left with grams on the top. And that's the unit we bring over here. So it's 0.217 times 46.1, and we get 10 grams. So this is basically the same thing. Now we're going to do 2 problems of this, and then we're going to put everything together with our gram to gram conversion. So please type this in the chat when you got the answer. So how many grams are in 0.357 moles of N2? The molar mass of N2 is 28 grams per mole. So this is you start off with the only information you have that's not the molar mass, and then you convert. I'd recommend a calculator for these problems. It's kind of tedious calculating them by hand. It's doable, of course. Okay. I'm gonna go over the solutions now. So we're gonna, as always, start off with what we have. We want to start off with our moles. So we have 0.357 moles of N2. We want to convert moles to grams. The only way we could convert moles to grams is the molar mass. Do we want the 28 on the top or the bottom? We want it on the top, so the moles cancel out. So we do 28 grams of N2 per 1 mole of N2. And notice that the moles of N2 cancel off with the moles of N2. So we end up multiplying these two numbers, 28 times 0.357. The answer we get is 10. And then the units that are remaining, which is grams of N2. So we have 10 grams of N2. So that's how we do this problem. So it wasn't that hard. Yep. And now our last problem before our grams to grams conversion. So how many grams are in 2.74 moles of HCl, which is hydrochloric acid? So for hydrogen, the molar mass is 1, and chlorine, it's 35.45. So you can honestly add up these two and get the molar mass of HCl. So this problem, I didn't give you the molar mass, but you can easily calculate it from the periodic table. So if I don't give you a molar mass, or if the teacher doesn't, that means you have to calculate it yourselves. So I'll give you a couple more seconds to think through this one. Let you plug it into a calculator. Okay. So the first thing we need to do is calculate the molar mass of HCl. There's 1 hydrogen and 1 chlorine. So you just add up these two numbers, which gives you a molar mass of 36.45 grams per mole. And let's start off with what we have. The only information we have now here is 2.74 moles of HCl. And MOL is a shorthand for moles. You might see that a lot. And then we need to use our molar mass. And this time we want the grams to be on the top, so the moles cancel off with the bottom. So we have 36.45 grams of HCl per 1 mole of HCl. The moles cancel out. We multiply 2.74 times 36.45. We get around 100. And then the units that are left is grams of HCl. So that's our answer. So that's how you do one of these problems. Pretty basic. So now, since we did the legwork, we're gonna do the last 15 minutes. Last section of the class is we're gonna put everything together with a grams to grams conversion. So here's our equation. H2 plus O2 yields 2H2O. That's hydrogen gas plus oxygen gas makes 2 molecules of water. And the question is, suppose we have 4 grams of hydrogen gas. How many grams of water is formed after reacting with excess oxygen gas? So we don't ask for how many moles of H2O is formed, we ask how many grams. So we start off with the grams. We have grams of hydrogen gas, and we want to go to grams of water. So this is basically a grams to grams question because we're going from 1 gram to the other. So that's what I mean by grams to grams. So this is a 3-step problem. We have to first convert grams to moles. So we need to convert grams of H2 to moles of H2. We just learned how to do that, or reviewed how to do that. 4 grams of H2. The conversion factor between grams to moles is molar mass. So by the periodic table, or you should know hydrogen is 1. So it's 2 grams of H2 per 1 mole of H2. So that's how we do our first conversion. And then once you do that conversion, you see that the grams actually cancel out. So 4 divided by 2 is 2 moles of H2. So that's what we have. So that's our first step, grams to moles. So that's what I had, moles to H2. So our step 2 is we need to convert moles to moles. So we have the number of moles of H2 and we want to convert it to moles of H2O. So we used balanced equation 1 to 2. So 2 moles of H2. We have 1 mole of H2 to 2 moles of H2O by the balanced equation. And as usual, we cancel out the moles of H2. So we get 4 moles of H2O. So now we have the number of moles of water. And from here, it's really easy to get moles to grams of water by just doing molar mass again. So our last step is taking the moles, and we're converting the moles we have to grams. So I'll continue writing on this screen. The molar mass for hydrogen is 1 and oxygen is 16. So, but we have 2 hydrogens, so it's 2 times 1, which is 2, plus 16, which is 18. So the molar mass is 18 grams per mole. Now, should we multiply it on the top, or do we put 18 grams on the bottom? We want to put 18 grams on the top, so we could cancel out the moles of water on the bottom. And once we cancel out the moles, we're left with our grams. So it's 18 times 4, and it's 72 grams of water. So that's our final answer. So this 3-step problem, we had to convert. We started off with grams of hydrogen gas. We converted the grams of hydrogen gas to moles of hydrogen gas to moles of water, then moles of water to grams of water. And that's how we solve one of these long problems. So as a recap, we convert grams to moles, then moles to moles using the balanced equation reaction, and then moles to grams. So I want you guys to do this sample problem, but in this problem, we're going to work on it 1 step at a time so you guys can get used to how to solve these types of problems. So we start off with 32 grams of oxygen this time. It's the same equation, hydrogen gas plus oxygen gas yields water. So suppose we have 32 grams of oxygen gas. How many grams of water do we have after reacting with excess H2? So step number 1 is always grams to moles. So please type into the chat how many moles of oxygen we have. So I'm not asking how many grams of water we have at the end. We're doing it in one step. So let me write it on the board. So our step number 1, we want the moles of oxygen. Oxygen gas, sorry, not moles of oxygen, the moles of O2. So we have 32 grams of oxygen gas. We want to convert this number to moles. And remember, the only way to convert between grams to moles is the molar mass. So, oh, sorry, I didn't give you enough information. The molar mass of oxygen is 16, and the molar mass of hydrogen is 1. So that means the molar mass of O2 is 32, and the molar mass of water is 18. I'm sorry, I forgot to give you that information. You kind of need that to find the answer. So, we start off with 32 grams of O2. The molar mass of oxygen gas is 32 grams per mole. Now the question is if we want to put it on the bottom or the top. Sorry, I just yes, there's someone who helped pointed me out that this equation wasn't balanced. I'm sorry I didn't catch it earlier. It's not balanced. There should actually be a 2 in front for the hydrogen. So our last calculation was wrong. But for this calculation, that's kind of irrelevant since we have oxygen gas and not hydrogen gas. Thank you for catching it, Matthew. It wasn't a balanced equation. I'm sorry for not giving you a balanced one. But the molar mass of oxygen gas is 32 grams of oxygen per 1 mole of oxygen. So as you can see, the grams of oxygen cancel out. So you're left with 1 mole of oxygen. And then the 1 mole of oxygen, you need to convert moles of oxygen to moles of water. And it's a 1 to 2, 1 mole of oxygen, 2 moles of water, because that's the balanced equation, a 1 to a 2. You cancel out the moles of oxygen and you get 2 moles of water. And now the last thing we have to do is convert moles of water to grams of water, and that's the molar mass. We use 18 grams, and the 18 grams are on the top, so the moles can cancel out. And then you get 36 grams of H2O at the very end, I believe, if I'm not wrong. Yep, 32 grams of water at the very end. So this is how we do a problem. It's not that long if you know all the steps. We need to convert from grams to moles of O2 and moles of O2 to moles of water. And then after that, we can easily convert moles of water to grams of water. And I'm sorry about that balanced equation again. So let's fix that. So the answer key is going to be wrong since I didn't realize I didn't balance the equation. There should be a 2 in front of the hydrogen gas. So the answer key for this problem will be wrong since I didn't catch that. So suppose we have formed 27 grams of water. How many grams of hydrogen gas do we need to react with excess O2? So this part about excess O2, that's just to say that oxygen isn't limiting. So we have plenty of oxygen to react. So we can use our calculation. So for this one, this problem is exact same. You need to convert grams of H2O to moles of H2O, moles of H2O to moles of H2. And this conversion is the balance equation, and moles to H2 to grams to H2. And each one of these individual 3 steps is the section we just covered in 13.1, but we're smushing everything together now. So our first conversion is grams to moles. And to do that, we're going to, of course, use molar mass. Similarly to moles to grams, we can also use the molar mass. The molar mass of hydrogen is 2. The molar mass of oxygen, water, is 18 grams per mole. So grams to moles, we use molar mass, and then moles to moles, we use the equation, BE, which is the balanced equation, which is this. Sorry for not balancing it earlier. So let's start off with grams of H2O. So we have 27 grams of water. To convert it to moles of water, we need to use the molar mass, which is 18. So this time we need the grams to be on the bottom to cancel out the grams on the top. So after we do this calculation, we get a 1.5 mole of H2O. So we've done the first step, check. Now we need to do the second step, moles of H2O to moles of H2. The balanced equation gives us that ratio, and we want the moles of H2O on the bottom. So looking at the equation, it's 2 moles of H2O over 2 moles of H2. Of course, I'm just taking this coefficient, and sticking them into a fraction, since we know that this fraction equals 1. We could cancel out the moles of H2O, and we know that these cancel out. 2 divided by 2 is 1. So we're basically left with 1.5 mole of H2. And we're done with this equation. And the last thing we need is moles of H2 to grams of H2. And the only way we could get that is the molar mass. So we have 1.5 moles of H2. We know 1 mole of H2 is 2 grams of H2 by the molar mass. And if I didn't give you the molar mass, I'll give you a periodic table so you can easily find the molar mass. And then you can cancel out the moles. and we're left with 3 grams of H2. So that's our final answer. I'm sorry this answer key was wrong because I didn't have the 2 out here, but the answer should actually be 3 grams of H2. Okay, so that's our lesson for today. So today we reviewed grams to moles to moles, and moles to grams conversion review, which is an important part of stoichiometry. And then at the very end, we had a grams to grams conversion. For our homework today, 2 of the problems are going to be pretty simple. It's finding the molar masses. So using a periodic table to find the molar mass. And then the last 2 problems are grams to grams conversion. So there's this long conversion, and if you need help, just email me, or you can also have multiple attempts during the homework, so don't feel limited. You can try multiple times. And there's 4 questions. I'll give you written feedback, and if you have any questions on the course, please contact me. Thank you for attending the lesson today, and I would like to mention that there's 2 more courses, 2 more lessons in this course. And our last course will be a review, and next course I'll try to come up with something cool and new to learn. Thank you for attending, guys. See ya.